Hello, everyone. We're Team 2, and my name is Michael Furrow.
I'm Frank Leonard.
I'm Richard Robinson.
I'm Emma McKay, and our project is a field-scale investigation of carbon dioxide enhanced oil recovery in tight shale reservoirs. We're doing everything from reservoir simulation to project economics. Because of the increase in global carbon dioxide emissions and the fact that global demand for fossil fuel energy is ever increasing, carbon dioxide enhanced oil recovery has the potential to be a viable solution in order to significantly aid in supplying these necessary energy resources. Our project focuses on the potential that is held in tight shale reservoirs. Being that shale reservoirs typically possess such low values of permeability and porosity, the ability to produce these types of formations economically by conventional means alone is extremely hindered. These low initial recovery rates leave vast amounts of unproduced original oil in place underground worldwide. The reservoir changes that occur as a result of carbon dioxide injection provide much more favorable conditions that allow for increased mobilization and production of the oil. Frank will later discuss the mechanics of these changes.
So, what is enhanced oil recovery? EOR is a form of recovery in which several techniques are utilized in order to maximize a well's production after its primary depletion. This is the point at which reservoir fluids are no longer being produced at an economic rate. So, there are three conventional types of EOR in use today. First, thermal recovery through the use of steam or fire. Second, chemical injection. And third, gas injection, either miscible or immiscible. This is the most common type of EOR and will be the focal point of our project using CO2 injection. Now, when CO2 is pumped into the reservoir, it becomes miscible with the oil trapped in the shale. CO2's miscibility with oil leads to a change in properties of the reservoir fluids, like viscosity reduction, oil swelling, interfacial tension reduction, and light components extraction, all of which allow for the reservoir fluids to flow more easily. So, is CO2 injection economically feasible? While the introduction of hydraulic fracturing has made shale production a profitable endeavor, it still only produces about 8 to 10% of total oil in the reservoir. Now, with the use of cyclical injection, production can be increased in some cases by 25%. And whenever you're dealing with a 25% increase in fluid production, this can lead to an increase in profits as well. So since oil prices are in constant fluctuation, it's important to weigh the costs of such a project to make sure that it is in fact profitable. Now, for the cost of CO2 injection, with the oil market at its current level of about $58 per barrel, companies operating in areas like the Permian and the Eagle Ford are in a great position to maximize their profits. Due to the cheap cost of CO2 and vast infrastructure in these areas, there is a unique opportunity to take advantage of EOR projects like cyclical carbon dioxide stimulation. Now, with the cost of CO2 typically around $18 per MCF and requiring a range of about 100 to 400 MCF per net foot of pay, we can get a general idea of how much CO2 is required for certain projects. So here we used data obtained from a Halcon and a Rosehill investor presentation, and we're able to calculate increase in profit for an example well in the Wolfcamp B formation of the Delaware Basin at this $58 per barrel oil price environment. Now, as you can see, this well had an expected ultimate recovery of about 1.3 million barrels of equivalent at 55% oil cut in a reservoir with 350 feet of pay. Now, from that, we were able to calculate the cost of the CO2 itself in this reservoir with 350 feet of pay, and that came out to about $1.89 million increase in the cost of the overall project. Now, this was neglecting the service cost of such a project, but then we were able to calculate the revenue from the production of oil both before and after the 25% increase in production due to this injection and CO2 soaking. Now, after that, we were able to calculate an increase in revenue of about $8.57 million. Now, while only a basic calculation, it shows that the increase in revenue does outweigh the initial cost of such a project.
Our main project goal is to deduce an argument as to why carbon dioxide enhanced oil recovery could be suitable for shale reservoirs from a technical as well as an economical standpoint. The first step in determining this will be obtaining experimental and computer simulated data, and the second step will be analyzing this data and making conclusions on our project goal.
In order to achieve project goals and objectives that Michael has just previously stated, we're going to need to run an experiment and a simulation to prove these. First, with the experiment methodology, we're going to need to prepare tablets that will be 1 inch by 3 millimeters in a circular shape that will be created from Marcellus core that LSU has provided from us. We will then rinse these tablets in distilled water and dry them at 122 degrees Fahrenheit for 24 hours in the oven. We will then dip these dried tablets in a toluene solution for 24 hours to remove any fatty acids that were absorbed by touching them. Once we do this, we will repeat step 3 again, which is dipping them in a toluene to make sure that they are very clean. Then we will try to simulate an oil-wet, saturated reservoir by soaking the tablet in crude oil and aging it for 12 days at 158 degrees Fahrenheit in the oven. After confirming that the sample was oil-wet, the tablet will be removed from the crude oil and will again be dipped in the toluene solution to make sure that it is clean. After it is confirmed that it is oil wet, we will soak it in a carbonate brine solution and also a NaCl simple brine solution, so we'll be able to see the differences and effects of the CO2 and how it positively benefits the rock. From this, we will examine the visual wettability changes that are directly related to oil recovery. Also, we will run a simulation, and with this simulation, we will gather the reservoir and fluid data and input this into CMG, or the Computer Modeling Group's reservoir software. We will develop a model reservoir, and then we will run a simulation. With this simulation, we will gather data from the results that show how much production can potentially be gained. Now that we have an experimental procedure in place, we need to begin looking at what goes into the experiment and how to budget for it. Items that will not be included in the budget because they are provided by LSU are the oven, the brine solution, the shale cores, the carbonated brine, the Pyrex beakers and Erlenmeyer flasks, and the autoclave glove. That means we will need to budget for petri dishes, toluene solvent, distilled water, and latex gloves. Also, we have set aside $3,000 to send 2 students to CMG training in Houston, and another $470 for travel expenses, whether it be gas or food when we're in Houston. Now, we will try to email them and see if we can't get a complimentary seminar, but as of now, it's $3,000. Next, an HSE moment for our experiment. There are only 3 potential hazards in our experiment, which is the toluene, which we recommend wearing gloves and eye protection for, because if you get exposed, it can cause irritation in the eyes or nose. Also, with the crude oil and carbon dioxide, we just recommend that you avoid the fumes because they can cause dizziness and confusion if you are exposed to too much of it. There's one piece of hazardous equipment in our experiment, and that is the oven, which will be used to up to 158 degrees, so we need to stay away from that and use proper equipment when handling hot equipment.
Here we have a rough timeline of goals and checkpoints to accomplish in the spring. You can see the individual tasks as well as start dates and end dates and the number of days we believe it will take to complete. It is important that we follow this because if we get behind in a single step, we will not be able to move on. For example, if we cannot start our reservoir simulation unless we've learned CMG, and we cannot inform data or an economic analysis without data obtained from the laboratory and simulations. This is why we have given ourselves ample time, as well as a few gaps, to allow us to fix any mistakes we might have along the way. The most important goal of the break will be for us to continue to learn CMG. If we don't have a good understanding of it, we'll get very far behind and may struggle to reach deadlines. One way we think we can avoid this is to attend a CMG session over winter break. We would also like to be able to start on the very first week of school in the spring, and that takes everyone in the group being familiarized with each step and each purpose of the project. Again, our ultimate goal is to perform a field-scale investigation of carbon dioxide enhanced oil recovery in shale reservoirs. This consists of a CO2 EOR computer-based simulation as well as experimental analysis. We will then take the data acquired and then finalize conclusions. We hope that we can determine CO2 EOR effective.
Thank you for watching. We hope that you find the potential in our project proposal to be as interesting as we hope it to be successful.